In trigonometry, the most important thing is the angle you're coming from. So, sine of pi over 3 is opposite over hypotenuse, 12 over 13. Whereas from pi over 6, cosine is adjacent over hypotenuse, which is still 12 over 13. So, there you go. All we're doing, well, I think all we're doing today, is SOHCAHTOA, 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 SOHCAHTOA. Just this, and this. The reason I did it like this is so that you'd get used to seeing angles in radian measures. That is the exact same as a 30, 60, 90 right triangle. They're just in radians. Of course, well, it doesn't matter. Questions over the Dom. Alright, then if some of y'all want to start up some notes, and who am I getting? Holly, thank you so much. Holly's going to come around and pick up the Doms. Today is Friday. Directions. Use the Pythagorean theorem to find the third side of the triangle, then find all 6 trig ratios from theta. Pythagorean theorem. A squared plus b squared equals c squared. Without exception, just like, you know how like every test I predict something that somebody's going to do? Someone is going to use the Pythagorean theorem incorrectly on the next test. Because which side is C in a right triangle? The hypotenuse. And when we do number 3, someone is going to use 21 squared plus 29 squared equals C squared. Is this side the hypotenuse? No. Please do not do that on the test. Please. Okay. So for number 1, A squared plus B squared equals C squared. That's 144 plus 81 equals C squared. 225 equals C squared. What's C going to be? 15. Now all we have to do is find our 6 trig ratios. Sine of theta, cosine of theta, tan of theta, cosecant, secant, and cotangent of theta. Alright. What's sine of theta going to be? That's very good. Opposite over hypotenuse. 9 over 15. I will write this on the board. Although this is something you need to have in your notes, and even better would be in your mind. SOHCAHTOA. Sine. Opposite over hypotenuse. 9 over 15, which reduces to 3/5. Very good. Cosine of theta is what? Adjacent over hypotenuse. 12 over 15, which reduces to 4/5. Tangent of theta, opposite over adjacent. Opposite over adjacent, 9 over 12, 3/4. And then we just flip them for the second 3. Well, this isn't very. 5/3, 5/4, and 4/3 for the second 3. Yes, ma'am. That is the perfect definition for it. Yes, that is right. In fact, that's how I always describe it. It's the one that it's touching that's not the hypotenuse. Which is exactly why you're never, ever, 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 ever going to find SOHCAHTOA for a right angle. Because that wouldn't make any sense. The opposite would be the hypotenuse. So it'll always be for one of the acute angles. Alright, number 29. We have to find the third side. It's not the hypotenuse, so you can call it A or B. I'll choose to call it A. And you have to solve it like a dece. A squared. Now I'm going to need somebody to punch in 29 squared minus 21 squared for me. Because I'm not going to do it. 29 squared minus 21 squared is what? Yes. 400 even? Alrighty. So, take square root. What is A? 20. Trig time. Sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotangent of theta. Alright. Who wants to help me out with sine? Diana, what's sine of theta? Perfect. Sarah, what's cosine of theta? I'm sorry? It's alright. You kind of mumbled, I couldn't hear you. Jocelyn, what's tangent of theta? Very good. And Alyssa, how do I find the second three? That's exactly what you do. The only thing you have to remember is which one goes with which. Cosecant goes with sine, secant goes with cosine, and cotangent obviously goes with tangent. Muy bien. Questions? We're doing this a lot today. Just a whole lot of different variations of this. So if you're good with SOHCAHTOA, then you should be good with this lesson. Okay, now, here was the point of the dumb. We're going to answer these questions in a second. They're actually much more straightforward than they look. Here's the point of the dumb. In fact, let me just go back to the dumb. Well, no, I'm not. I'm going to go back to this one. Okay, somebody tell me, what is sine of 30? 1 over 2. Someone different tell me, what is cosine of 60? 1 over 2 again. Very good. Those are called cofunctions. They're cofunctions if, now I'm going to skip ahead a few slides to talk about this. When you have two complementary angles in a right triangle, in other words, the two angles of a right triangle, their inverse trig functions are going to be the same as each other. So let's just make up an example. Let's say we had a right triangle, and I'm going to completely make up the sides here, and I apologize if they didn't work out because I'm making up this example. Let's say this is 21 degrees, and what would this one have to be? What would the third angle have to be? 69. Very good. Now let's say this triangle was a 3, 4, 5. It's one of those nice perfect ones. What is sine of 21? 3/5. You just look up here. I realized since I made up the example, if you were to punch in sine of 21 in your calculator, you'd probably get something different. But now, a cofunction means what other trig function in that exact same triangle would give me also 3/5? Cosine of 69. It'll always be the supplement or the complement to that angle, and then just the opposite trig function, sine or cosine. That is the point of these. What would be a cofunction of sine of 7? Cosine 83. What would be, this one looks so good here. What would be a cofunction of cosecant 25? What's the flip of cosecant? Not the flip, what's the, yeah, I couldn't think of the right word. This would be secant of 65. Now, when in doubt, just draw yourself a random triangle. It doesn't even matter if it's perfectly to scale or if this would work out in all the little rules. Let's just make ourselves a little example. If that's 25, this would have to be 65, right? Just make yourself random sides. It doesn't even matter if they work right now. We're just seeing if the ratios would be the same. Cosecant is the flip of what? Sine. So sine of 25 would be what, 3/2? Sine would be 2/3. Cosecant would be 3/2. Now we're just going to, we said it would be what? Secant of 65? So just check it. Cosine of 65 would be 2/3. Secant 3/2. It is the same thing. You can always, the whole point of that is you can make an example. When in doubt, just make an example for yourself. And sure enough, but you're right. Secant 65. It'll always just be the supplement, complement, and the opposite function. 25 we may have to draw. Remember, when you're confused, just draw yourself a triangle. So, we've got a right triangle. We're going to call this pi over 9. Now, if things add to 90 in degrees, what do they need to add to in radians? What's the same as 90 on your unit circle? Now that's 360. What's the same as, was it? What's another question? What is the same as 90 pi over 2? Thank you. These two things, just like they would have to be 60 and 30 adding to 90, have to add to pi over 2. So you need to take pi over 2 minus pi over 9, just like you would take 90 minus 60 to find a 30-degree angle. Ugh, gross. We need common denominators. What's a common denominator? 18. So that'd be 9 pi over 18 minus 2 pi over 18. Sorry, that's just an 18. I don't know what happened. So what would that be? 7 pi over 18? And that would be, now, tangent. Now again, let's just make ourselves up number examples. It doesn't even matter if they work. Tangent of pi over 9 would be what? 1/2? What is another function? What's another trig function that would also give you 1/2? Cosine would be 1/3. Tangent would be 2 over 1, but how could we flip it? Cotangent. The cofunctions. Now I wanted you guys just to think about it, but I'll just tell you. Cofunctions with one another. Now here's another reason I don't usually make a chart about this. This will be like, you know, this is one of the more inconsequential facts in the entire chapter, so don't make a huge chart and it about your notes. Because then when you start looking through your charts later for something, you're going to think this must have been important. It's really not. But every function has a cofunction. Sine has cosine, secant has cosecant, which is why they're named that, and tangent has cotangent. So I guess I really didn't need any explanation, did it? If it has a co in front of it, that's its counterpart. Sine, cosine, secant, cosecant, tangent, cotangent. And last but not least, someone do some subtraction and tell me what the cofunction for 27 would be. Pi over 2 minus 2 pi set. I'm going to stand right here. Okay, the weekend passes. I will stand right here. What? Oh, people are calling up. What is the answer to 27? Are you serious? You gonna play this game? We can finish and watch like Not to Be or something. Okay.
No, don't tell them.
Hey.
And I asked her about that. Who was it that always gave that? No, somebody. It doesn't matter. What was it? It would be sine of something. Pi over 2 minus 2 pi fifths. Pi over 2 is 5 pi over 10. 2 pi fifths is 4 pi over 10. What is 5? Was it? Bridget, what did you say? Was it not you? No, it would be. Thank you, yes. The answer to 27 is sine of pi over 10. Sine of pi over 10 is the cofunction for sine of 2 pi fifths. Again, refresher. Just like you subtracted these from 90, you have to subtract these from pi over 2. Just like we did that one. You'll have to do some common denominator stuff, but you should have gotten sine of pi over 10 when you changed your denominators and such. Oh, I'm sorry? Sure. Also, if you're like, I don't like subtracting from radians, you can convert it to degrees. Remember, you know how to do that too. So you could always just convert these to degrees and then subtract it from 90. But here is the actual process for subtracting. So you have pi over 2 minus 2 pi fifths. What's our common denominator going to be? 10. So how can I change 1/2 into tenths? Muy bien. Double both of those. Yep. And that's where we got 1 pi over 10 for our answer. And then it's always just a cofunction. So sine of pi over 10. Does that make sense there? Maybe. Let me ask you this. Did these make sense? So is it just the subtraction process that's throwing you? To degrees? That's fine. If that's what you wish to do, then that's fine. Oh, I have no idea what that would be in degrees. What? Well, we need a common denominator of 10. So multiply these by 5 and these by 2, so it goes to 10. Latifa. It was cotangent of 7 pi over 18. Other questions? Okay. Now, That was just so we could knock out that slide nice and early. We still have to come back and do this slide. Now, every single thing you need for this is on the board. Or I guess it will be in your book when you're doing it. Everything. What is cosine of 30? Look at the picture. What's cosine of 30? That's right. Or you could just look at your unit circle. Secant of 45. Does it matter? If it's isosceles. Very good. It'd be 1 over radical 2 flipped because it would be cosine. You know what? Let me actually work these out. Secant is the flip of cosine. Cosine would be 1 over radical 2. But since it's secant, you're flipping it to radical 2 over 1. Yay! No rationalization necessary. Tangent of pi over 3. Now, again, use your unit circle for the conversions. What is pi over 3 on the unit circle? It is 60. So tangent of 60 is still up here on the board. Opposite, just kidding. Opposite over adjacent. Radical 3. Now we're going to do the exact same thing. It's just we're going to put them in little math sentences. Sine of pi over 4. 1 over radical 2. Now, we'll worry about rationalizing in a second. Minus cosine of pi over 4, which would be 1 over pi over 2 again. I mean, radical 2. So what would that equal? Anything minus itself at 0. We're just taking these values straight from the board. Slash your book when you do it. All right, number 17. Sine of pi over 3. What's pi over 3? 60. So what would sine of that be? That's true. I guess you could just use your unit circle for all these. You don't even need these pictures. But radical 3 over 2 times, what's cosine pi over 4? You're exactly right. 1 over radical 2 minus tangent of pi over 4. 1. So now we need to do that whole thing. Multiplying straight across. That's radical 3 over 2 radical 2 minus 1. Okay. The directions ask for a specific answer, which means there's a little algebra to play with here. So, here we go. First thing we have to do is get a common denominator. I say we subtract, don't do our rationalization to the end. What is 1 in terms of 2 radical 2's? Very good. 2 radical 2 over 2 radical 2. Hey, look, now we have a common denominator. So, 3 times, oops, that's not true. 2. What happens when you multiply radicals? Oh, just kidding. Why is he multiplying? This is subtraction. My bad. Over the common denominator. Now, what is the problem here? What do I have to do? That's exactly right. Now, when you do that, you know what? Let me go to the right. Look who's so smart. That's right. That becomes radical 6 minus 2 radical 4, which of course you can reduce in a second, over 2 times 2, which would be 4. Because it would be 2 times square root of 2 squared, which is 2. What is square root of 2? 4. 2. 2 times 2 would be 4. Now, you cannot subtract the 4s. Cancel the 4s. You're done right here. There's nothing else you could do. You could break this up into 2 fractions like I'm sure the book does, but I like to just keep it like that. So, yeah. Because they're married with subtraction. If you try to cancel something that's bonded with addition or subtraction, it's like mathematical adultery. It's wrong. You can't do it. It is married. Not making light of adultery, just using it as an analogy. Okay. Questions over that problem? That's probably as hard as it gets. Good. Try 19 on your own. Try 19. Yes, I can. Hold on. I'll go over in just a second. Ah! Alright, here's number 19. I left that stuff on the bottom of the last problem in case you were recording it. Number 19 has nothing to do with what's already written on the board. What is that? So we can unit circle? I would encourage you to do so. Nope, your unit circle is everything you will ever need. No. Okay, you want a triangle? It's in section 4.3 in your book. Yes. Yes, they are. They are multiplied. They're in your book. La 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 la. I very, very much enjoyed meeting some of your parents last night. Although it was only like 5 of you. But made the time go by. Somebody even gave me a peanut butter brownie, but I won't say who. It was very good. Made my night. I only had one parent come in ranting in a raven. But it was okay. 20 minutes after they stopped cussing me out, I'm like, you have the wrong teacher. He's next door. It's kind of funny. Like, which means two things. A, you didn't read the sign, and B, that's what's wrong with your child. Just kidding, that never happened. But I would have said that if it had. Oh, it didn't really happen. I was just making that up. I tend to lie a lot. It's kind of my thing. Oh no, you really do have homework. Hey Sam, you're going to walk me through this problem. Do you have your unit circle in front of you? Excellent. Hey Sam. Shh. What is tangent of pi over 3? We're going to do it together. Alright, how about this, Sam? Shh. Tangent stands for what? Sine over cosine? Well, so what's sine of pi over 3? Muy bien. What is cosine of pi over 3? Very good. Plus, what's cosine of pi over 4? Excellent. And what's tangent? Oh, just kidding. What is sine of pi over 6? Because tangent's not on there, so I'm just having him give me the sine and the cosine. What's sine? And what is cosine? What were you saying, Sarah? Yes. No. Yes. No. Oh, you guys are saving me the reducing? That is so sweet. Okay. So, I've been told this one just reduces to 2 radical 3, because of the 2 here. Plus, what does this whole thing reduce to? Let's do it together. There are so many people talking. Brianna's going to take it now. Go. Oh, is what? Okay. So, multiplying, what's that, radical 6 over 6? Now, if you want to be a little overachiever, you can, yes, we should. How do we add these two things? Common denominator. That's right. What's our common denominator? So multiply the first one by 6. So does that become... Oh, but we still can't do much. 12 radical 3 plus radical 6 all over 6. Latifa first. Okay. Where'd you get 1? Okay. Okay. Cosine. Okay. You said you got 1 over radical 2? Rationalize that, and you should get radical 2 over 2. That's where we got that. Okay? Now, the second one. Latifa, what did you say you got? Rationalize it. And there you go. That's how we got that. Sarah, what was your question? Questions? Where did these come from? Well, I was having Sam help me with unit circle. And because not all of them tangent is given, I just did what you're supposed to do to find tangent. I took sine over cosine. So I took sine of pi over 6 over cosine of pi over 6, which reduced down to this. Which I skipped that step because somebody just told me. But it reduces down to that, evidently. Yeah, you cross multiply, 2's would cancel. Yeah. Yes, ma'am. Yes, we can. Let's do another. Ooh, I'm going to mix it up, do degrees and radians. Yes, he did. You don't want to do degrees? It's the same difference. Here we go. So, how about... Oh, yeah, it's going to go crazy. Negative 3 cosine of 225 minus 2 times cotangent, that's a sine, cotangent pi over 4 minus times sine 11 pi over 6. They should still all be on your unit circle. But I guess now you can't use the triangles. What? That's times. Okay. Here we go. Ashton, what is cosine of 225? Unit circle makes it happen. Negative radical. Thank you. Ashton, I'll choose you again. What is tangent of pi over 4? So you said 1? So what would cotangent of pi over 4 be then? It'd be 1 as well. And then, last one, Ashton. What is sine of 11 pi over 6? That is exactly what it is. Hey, for one I made up, this isn't that ugly. So multiplying, that's 3 radical 2 over 2 minus 2 times negative 1/2. So 1. So plus 1. You know what? I'm skipping too many steps. Bad, Mr. Crawford. Minus 2 times negative 1/2, which of course becomes positive 1. I'm really proud of myself for that problem. And if you wanted to combine them, which I'm not going to require, you can leave it like that. If you wanted to combine them, you need to make the 1 2 halves. Questions? You straight? Good to know. I heard that was on that video. I know now, isn't it, my girlfriend? I'll go home and call my wife Shoddy. Okay. Boy, what was that? What is that going to make my future child? Like extra shoddy? I mean, they're like is shoddy not? Is that not like I don't want to insult anybody. Is that not like ghetto for shorty?
Yeah.
So if someone's shorter than shorty, what would that make them?
Well, you don't have to. It's not salad.
Well, no, I realize that, but okay, okay. I just think. Okay, never mind. Never mind. Doesn't even matter. All right, all right. Moving on. Were there questions on that last problem? Oh, there's 7 more slides. So let's stop wasting time. No. This everything the rest of the day is like this. Everything. Oh, actually, that's true. And you would need a unit circle to do that. I mean, a calculator, which I don't allow you to use. So, ooh, I'm having a thought here. I'm having a thought here, Barbosa. Here's what we're going to do. Good movie. We are going to cut this up, and I'm also going to break up your... You're going to have a quiz on Monday over the unit circle, the things you do not need a calculator for. And then Tuesday, we're going to start doing things you can use a calculator for. So we are going to stop it today, and Monday you're going to have a quiz over that stuff. What?